Hello students, welcome to my YouTube channel Physics with Msir. If you are new to this channel, please subscribe the channel, and if you like the content of the video, please do not forget to like and share the video, because this will give me more motivation so I can bring more videos for you. Okay, today's topic, in the last video, I taught you how to find out lateral shift when refraction is taking place through a parallel glass slab. In this lecture, I am going to show you some of the beautiful facts. When refraction takes place through multiple parallel slabs, what happen, how to find out the related refractive index relation between different refractive indexes, as well as the concept of real depth and apparent depth. So let's start. So first of all, what I'm going to tell you, if refraction is taking place through multiple parallel slabs, then what will happen? Correct. So the topic is refraction through multiple parallel slabs of different RI. Yes, different refractive index. Okay. So let's make it a little colorful. Okay. So say for example, these are medium. Okay. And this another medium. Now, say for example, a light is falling like this. Light is falling like this. And assuming that the refractive index of this medium, absolute refractive index of this medium, is supposed to be mu1, this is supposed to be mu2, and this is supposed to be mu3, and this is supposed to be mu1. And I'm writing in this way, key mu1 is less than mu2, less than mu3. Then what will happen? I told you this earlier also, key first draw the normal. Okay, this is very important to draw the ray diagram. Now what will happen when this ray moves from medium 1 to this medium 2, that means it's moving from rarer to denser medium, correct? Because refractive index is lesser, correct? So what will happen? The light will bend towards the normal. We know that. So in this case, this light will bend towards the normal. Let's make it like this. So again, draw a normal. Okay, then what will happen? Since medium 3 is denser than medium 2, while this light ray will enter the medium 3, it will bend more towards the normal, correct? So this will happen. Okay, and again drawing a normal. Now watch it, what will happen. Now the light is moving from medium 3 to medium 1. That means from denser to rarer medium. So what will happen? It will bend away from the normal. And I gave a concept in the last video. Key, we always remember angle of incidence and angle of emergence are always same if these rays are passing through parallel slabs, correct? Now what will happen if it is I? Let's make it R1. If it is R1, so this will be obviously R1. And let's make it R2. And so it will be R2 and this will be R. Now I'm going to apply the Snell's law. Correct? I'm going to apply Snell's law. Watch it carefully. Sine of I by sine of R1 means I'm doing it for medium 1 and medium 2. So it is moving from medium 1 to medium 2. So what should I write? It is the refractive index of medium 2 with respect to medium 1. So we must write it like this. Mu of what? This is refractive index of medium 2 with respect to medium 1. So let's write this equation as 1. Now watch it. If I do this calculation from medium 2 and medium 3, so what should I write? R1 is the angle of incidence and R2 is the angle of refraction. So sine of R1 by sine of R2 is equal to, it's moving from 2 to 3. So what should I write? This is equal to mu. It is moving from which medium to which medium? 2 to 3. So it is refractive index of medium 3 with respect to medium 2. Now, doing this calculation for medium 3 to medium 1. So we must write it like this: sine of R2 by sine of I, which is equal to moving from medium 3 to 1. So mu 3, 1, that is refractive index of medium 1 with respect to medium 3. Now what I'm going to do, I'm just going to multiply all these three equations, okay, side by side. So look at this. Sine of I by sine of R1 into sine of R1 by sine of R2 into sine of R2 by sine of I is equal to what will happen? Look at this. This into this into this. Okay. So watch it. This sine I get cancelled with this, sine R2 would get cancelled with this, sine R1 get cancelled. So we obtain from this a very clear relation. What is that? Mu 1 2, mu 2 3, mu 3 1 is equal to 1. Student, please remember, this is a very, very important trick in solving the relation between the refractive indices. Correct? Always remember the technique. Look, this is subscript and this is superscript. If 2 is subscript and 1 2 is superscript, this will get cancelled. These 3 get cancelled, 1 get cancelled, answer is 1. Or you can modify the relation in this way also. Mu 1 2 into mu 2 3 is equal to 1 by mu 3 1, which we can write in this way also. Mu 1 2 into mu 2 3 is equal to, if I interchange this will be mu 1 3. Now look, what is the technique of remembering this? This 2 in the subscript and this 2 in superscript, those 2 gets cancelled. Look, only 1 left and 3 left is the answer. So this is the trick of finding the refractive index of a medium with respect to another, with several refractive indexes are given to you. Okay, so let's solve a problem related to this. For example, it is given for example, take a question. The absolute refractive index of glass with respect to, the absolute refractive index of glass is suppose X. Refractive index of an oil with respect to water is Y. Then find water with respect to oil with respect to glass is Y. Okay. And then find the refractive index of the oil with respect to air. Okay. So first of all, let me write down the given information. Correct. It is the absolute refractive index of glass. So what is that? Absolute means it is obviously with respect to what? Air. Correct. So let it write like this. A, it is glass. This is X. Write it like this. Number one. Next, what is given? Refractive index of an oil with respect to glass is Y. Refractive index of an oil with respect to glass is Y. With respect to glass, so we should write it like this: glass at the top and water at the bottom, because it is the refractive index of water, oil with respect to glass. Refractive index of oil with respect to glass. So we must write it like this. And it is suppose Y. What you need to find out? Refractive index of oil with respect to air. So our task is to find out A. This is the question here. So what we do? Look at this. Let's write it like this: mu Ag multiplied by mu Go. Why I'm writing like this? Look, since this G is placed in subscript and this G in superscript, so they will get cancelled. So what thing will left? The thing that will left is this, and our task is to find out this. Okay, because these glass will get cancelled, because these in subscript and these in superscript, these get cancelled. Only these two things are left. So what should I do? Now mu Ag is given. What is that? X. And what is mu Go? That is Y. So it is mu A. Okay. So this is the technique of solving the sum. Is it clear to you? Okay. So let's copy another problem. Okay. Suppose it is given the refractive index of question is the absolute refractive index of water is 4/3, and relative refractive index of an oil with respect to our water. Refractive index of an oil with respect to water is given 1.50, and refractive index of glass with respect to air, with respect to oil, is 0.8. Question is, find the absolute refractive index, absolute RI of glass. Okay, so how to solve it? Look at the technique. The absolute refractive index of water is 4/3. So it is given mu AW, that means 4/3, which you can write as 1.33, whatever you like. Correct? This is number one. Next, refractive index of an oil with respect to water. So write it like this: mu. Okay. Oil with respect to water, that means oil with respect to water, that means W, this is O, 1.57. And third is given refractive index of glass with respect to oil. That means this is equal to 0.8. And what we are doing to find out, that will we have to find out, that is absolute refractive index of glass. That is mu AG. This is our task, correct? So what I do here, what will I do here? Let me write it like this: mu AW, okay, multiplied by mu WO, okay, mu OG. Now watch it carefully. This WW get cancelled, this O get cancelled, this AG. That means this is mu AG, which is actually our question, correct? So what is the value given? Mu AW is 4 by 3 and mu WO, which is given 1.50 and it is given 0.8. This is mu AG. Now you can do this calculation very easily. So if you do this calculation, you can do it by yourself. The answer will come near about 1.596. Is it clear? So this is the technique of solving this kind of problem. Now, so now you people are quite clear by viewing all these lectures serially. What is refraction, what is refractive indices, what is absolute refractive index, what is relative refractive index, how to find out the relation between them, how to nurture them, correct? Now I'm going to show you a very, very important concept happened in refraction, that is called the concept of real depth and apparent depth. Actually, it's a very common sense when, say for example, a coin, or say for example, a tub completely filled with water. If you watch if you try to watch the bottom of the tap, correct, from above the water and from outside, you will find that they are not similar, correct? You will find that when we were viewing it from outside, the thickness looks like slightly greater, but when you are viewing it from the top of the water, it is slightly lesser, correct? So the question is why this happened, correct? So this is the concept of real depth and apparent depth. So please try to understand this concept. It's a very interesting one. For an example, let's take a draw a diagram first, correct? So for example, this is, say for example, this is water. Okay, this is water. Now let's put a border on it so we can understand it better. And suppose there is a coin, okay, at the bottom of this top. Let us assume this is the coin. So let me mark this by C for coin. Fantastic. Now you are trying to view this from the top of the water, correct? Water surface. That means you are the observer, you are here and trying to view this coin, correct? Now let us assume the depth of the water is supposed to be h. Now what will happen? Okay, now watch it carefully. Now always remember you need to draw at least 2 rays to get the position of the image, because if they are not intersecting at all, you will not able to find out any kind of image, correct? So this I think you have this idea. You already learned the laws of refraction and the chapter of reflection. There is already, I think it is already clear to you. So let me tell you something very, very important related to this now. So let me draw the ray diagram using some different color, correct? So let me use black color. So it will be much more better, correct? So one ray goes straight to your eye. This is called the normal one. And another ray is going like this. Watch this carefully. Clear? Watch this carefully. Another ray is going like this. Okay. Now, what is happening here? First of all, as I told you earlier also, we always draw a normal. This is very, very important. Okay. So this is the normal drawn. And let me put the sign of the arrow. So this is the arrow sign for the rays. Now, this point is supposed to be E. And this point is supposed to be B. And this point is supposed to be N. N means the foot of the normal. Correct? Now, if I apply laws of refraction, so it is medium 2, it is medium 1. So let me write down this as medium 2 and this is medium 1. Okay. Now, this is the angle of incidence. Let me mark it I. So this is the angle of refraction. Now, obviously, these rays, the ray which is along CA and the ray which is along CB are not obviously intersecting. So it is not possible to view the image. So if anyone wants to view the image, so what we need to do, remember, this is very important. I am doing this by red line, that these two rays must intersect. So for intersection, what I am doing, I am extending it a little backward. Correct? So this black line, this red line is actually the virtual one. Correct? So this is not actually existing. Okay, we are drawing it. Correct? That means this is called virtual ray. And these are all real ones. Correct? So what is happening? This real line and this virtual ray are intersecting at this point and creating an image I at this position. As a result of which, if you want to view the position of the coin, correct, from above the water, instead of finding the water at its own place, you will find the position of the coin at this point, correct? This is actually, this AI is called the apparent depth, and this CA is called the real depth, correct? Now I'm going to establish a relation very beautifully, key, how to calculate the value of this apparent depth. Okay. Now the technique is this. Look at this. Just applying Snell's law in general form. Okay. I taught you this earlier, mu1 sin I equal to mu2 sin I, if you remember. So mu2 is the refractive index of this medium. So let's write it mu2. Multiplied by sine of angle of incidence. Let us write this by sine of I is equal to mu1 sine of R. Okay. Now, what we do, let me write out this sine I. What is sine I? Look at this triangle base. If this is I and this is also I, correct? Is it clear? It means if this is R, this is R. From geometry, this is I, this is I. So if I consider the triangle ABC, so from this triangle, what we can view, sine of I is equal to height by hypotenuse. What is that? AB is the height. What is the hypotenuse? That is CB. Okay. And from the triangle ABI, what do we find? Sine of R is equal to height, that is AB, by hypotenuse BI or IB. Now let's do one thing better. This equation 1, this equation 2. So what I am doing here, I am putting this value in this equation. Okay, in this equation. So mu2 Sine of I means AB by CB, and mu2, this is mu2, mu1, sine of R means AB by IB. Okay. Now, watch this AB get cancelled. So what we can write? Mu2 by mu1 is equal to CB by IB. Now, a very, very important concept which I'm going to give you now. Look, in order to view this image of this object, these two rays are intersecting. And if you want to view this image, these two rays must go to your eyes. That means since aperture of our eye is very small, correct? These two rays, which are actually shown in diagram too far, actually this never happens. These two comes very close. Otherwise, what will happen? This ray will never enter your eye. Correct? That means since the logic is this, since the aperture means size, correct? Obvious, that means size of the eye, correct? Since the aperture of our eye is very small, aperture of our eye is very small, the point B and A actually lies very close to each other. Okay. So on that basis of approximation, what we can write, if B and A are very close, we can replace this CB approximately by, look, CA. And this IB approximately by IA. And if I apply these values in this relation, so what will happen? If I apply this relation in this, this value, this approximation in this relation, so the thing comes like this: mu2 by mu1 is equal to replacing CB by CA and IB by I. Watch this. Now, what is CA? CA is the actual depth that we call real depth. And what is IA? IA is nothing but the apparent depth. So, formula is real depth by apparent depth is equal to mu2 by mu1.